All right, so let's get warmed up today. Today we're going to talk about section 4.4 involving long division of polynomials, dividing them, which is a separate skill. It takes a little bit of getting used to, but it's not so bad once you get the gist of it. Let's practice these real quick, of course. We must simplify the following expressions. So let's go ahead and get distributing and see what we can do with that kind of junk. And here we go. Number one says 3ab times this quantity plus 4b squared times this quantity. So we're going to take the 3ab from the first one, distribute it in. So if you distribute the 3ab in, 3ab times 4a, 3 times 4 is 12. A times the a is an a squared, and the b is just chilling there. So the first term we written down should have been 12a squared b. Taking the 3ab times the 5b, well, a positive times a negative is a negative. 3 times 5 is 15, and ab times a b would be an ab squared. So there's the first part. For the second one, you're doing the same kind of thing. You're taking this 4b squared and putting it in. When you do, 4 times 2 is 8. You have an a squared and a b squared, so it doesn't really matter what order you write it in, but I encourage you to do it alphabetical. If there's no system at all, just write it alphabetically. You don't have to, but it'd be nice. And then 4b squared plus the 1 is just 4b squared. So it's all distributed out. I'm just going to look for like terms, see if there's anything I can put together. Here's an a squared b. I don't see any other a squared b's. I see an a squared b squared, but that doesn't count. They got to be exactly the same kind of variables involved, so that's not going to work. Here's an ab squared, another ab squared. No. In fact, there are no like terms to put together, so we're done with that one. And here's the answer for number one, and life is good. All right, moving on to number two. Number two is saying, hey, let's distribute this out. It's not going to take nearly as long. It's only 2 things here and 2 things there, so it'll be 4 things altogether. Starting the distribution, n squared times 2n cubed. Well, there's a 2. And the n squared, the n cubed turn into an n to the 5th. You add the exponents when you're multiplying. Do you know what you do when you divide things, like an x to the 5th divided by an x to the 3rd? Do you remember what you do with your exponents then? Subtract them. We'll get onto that today. Okay, n squared times 4 is just 4n squared, and the n squared has been distributed to everybody. Moving on to the negative 7. Negative 7 times 2n squared would be negative 14n, cubed. Cubed, not squared. And the negative 7 times the 4 is negative 28. So there it is, all distributed out, nice and clean. Let's just see if there's anything we can put together. There's not really. I got fifths and squares and cubes and constants. The only thing you might do, and again, this is optional, but I wouldn't strongly encourage you to do it, is to write it in the correct order. The standard form of a polynomial, the exponent should be going down. So it's not wrong if you don't do that, but it's preferred. It's like writing a quadratic like x plus x squared plus 3. It's just very awkward to write it like this, right? You like the x squareds first, and the x after that, and stuff like that. So there we go. That's it. So there's number 2. Lastly today, for our warm-up number 3, we're cubing something. So here's what I kind of always get scared about, and kids, I don't know. You guys got any ideas of what you could do for this real quick? A lot of people would just probably cube this and subtract it, and that does not work. So in case you are tempted to do that, anytime you try to distribute a square like this, a puppy dies. So look on the screen, and there's a dead puppy if you do that. So do not do that, okay? Please don't. You have to go the long way. What's it mean to cube something? What's it mean to square something? You multiply it by itself, right? If I say cube something, that means you got to multiply by itself 3 times. So this is not a simple problem, actually. You have to write it out, times itself once, times itself twice, and times itself 3 times. It is a pain in the butt to do, but we can do it. So you have to distribute 3 things out. How do you distribute 3 things out? You don't. You just do 2 at a time, correct? So this is going to take a little minute. Let's just do the first 2 together. So just these 2. We'll let the last one chill. In fact, I'll just write the last one again, just so I don't forget it later on. There's the last one. I'm just going to let it hang out. Distributing out the first 2. Here we go. 2x times 2x. Well, that'd be 4x squared, right? 2 times 2 is 4. X times x is x squared. Check. Next, 2x times negative 2y. Well, let's see, what will that be? 2x times negative 2y will be a negative and then a 4, and they both have an x and a y, so negative 4xy right there. And the 2x, that's the distribution from that. Moving on, distribute the negative 2y. Negative 2y times 2x, well, it's going to be a negative. 2 times 2 again is 4. And again, you have like a y times an x, but, you know, try writing a normal order. X times y would be probably better, just so it's an alphabetical order. And lastly, negative 2y times negative 2y. Well, a negative times a negative is a positive. 2 times 2 is 4. And y times y is y squared. So there's the first one distributed out. And I do see some like terms here. I see, and it's never a bad idea to put like terms together, no matter what you're doing. Here, these are the exact same things, right? Negative 4xy, another negative 4xy. That's a grand total of negative 8xy. So I can put those together. Always makes your life a little easier if you put like terms together as you go. All right. So now we got to do this stupid thing. Okay, let's get distributing. Here we go. 4x squared times 2x. 4 times 2 is 8. X squared times x is x cubed. So the 4x squared times the 2x is that. 4x squared times negative 2y would be negative 8x squared and y. So there's the result after you distribute the 4x squared in. Next, you're on to this negative 8xy thing. Well, here we go. Negative 8xy times 2x. Well, negative 8 times 2 is negative 16, right? I got an x times another x, so that's an x squared. And then there's also this lone y hanging out. So there's the negative xy times the 2x. Going on, the negative 8xy times the negative 2y. Well, a negative times a negative is a positive. 8 times 2 is 16. I got an x, and I got 2y, so a y squared. So that's what happens after I distribute the negative 8xy in. And lastly, the 4y squared. Let's put that in here. 4y squared times 2x. Well, 4 times 2 is a positive 8. You got an x and 2y, so xy squared. And very last, 4y squared times the negative 2y. Well, positive 4 times negative 2 is negative 8. No x's, but you got a y squared times a y. That's a grand total of a y cubed. So we made it. We distributed this thing out. Took a long time. And you'd be so wrong. Look how complicated this is. It'd be so wrong if you just cubed this, then minus cubed that. So don't do that, and the puppies die. Any like terms we can put together? I don't know. Let's scan. I've got an 8x cubed. Any just other x cubes? Nope. So there's an 8x cubed. I'm not even sure there are like terms. I'm going to find out. Here's an x squared y stuff. Any other x squared y's? Hey, there is one right next to it, right? Another x squared y. So I can put these two together. Any other x squared? No, that's it. So if I got negative 8 of something minus 16 of something, that's a grand total of negative 24 of that something. So we can put those two right together into negative 24. Anything else we can put together? Oh, look at the next two. They're like terms also. Here's an xy squared thing. Here's got an xy squared thing. So if I have 16 things plus 8 things, that's positive 24 things. So that would be positive 24xy squared. And the only thing we haven't really covered yet is this minus 8y cubed. So that's still hanging out there, and it doesn't go with anybody. So it's awkwardly just going to chill on the end right there. All right. So there is how you're going to do any distribution or addition or combining like terms. That's a good review of what section 4.3 was about. Here's your learning goals for the day. Please write them down real quick. Learn to divide polynomials. Take a polynomial divided by another polynomial. How do you do that? It might seem like a niche skill. Like, why would I need to do that? Why would I never need to take a x cubed plus 5x squared plus 3x plus 2 divided by x minus 9? Why do I need to do that? That's pointless. Actually, this skill is at the heart of the entire unit. You're going to be using this skill the rest of the unit. If you're not, you're probably not doing the unit right. So you need to get this one down today very well. It will follow you for a long time. Into pre-calc. It's like quadratic formula. This is one of those things that just keeps coming up over and over and over. Yeah, you're still using calc. There you go. See? It's never going to go away. All right. Here's your new homework over. You might want to jot this down real quick. Down at the bottom, homework 4.4. Found on page 245 of the online textbook. Of course, you're always welcome to go look at the online version of it with the problems already there in digital format. You could check. Do it on paper. Do it online. I don't care. 1 through 10 all, 18 through 28 even. That's due on Monday. Don't forget 4.3 is due today. So get that turned in or submitted online by 3 o'clock, or else it is late. And that's pretty much it. All right, let's get to the heart of it today. Get your notes out, get ready for that. Here we go. Today is section 4.4. Title of it is Dividing Polynomials. It's going to be fun. It's going to be fun. Sounds like you guys need a little bit of refresher, some Algebra 1 stuff, though. So we'll talk about that really quick. As a precursor, let me go ahead and give you some quick notes that you might need coming up on the board. Here we go. Let's write some rules down. First off, there's one rule you've been using all the time, and you already know what it is. What do you do with your exponents when you multiply things like x cubed times x squared? It's just x to the fifth, right? You just add them together, correct? Well, there's one rule you've been using all the time, and that's left over from Algebra 1, so that's an Algebra 1 rule right there. You've been using that. No big deal. That's something you know. Here's one that might start coming up today, and this is from Algebra 1 also. It's about division. When you take an x to a power divided by another x to a power, this time what you do with your exponents is, well, these are opposites of each other. There's a nice thing in math, by the way. This is multiplication, right? And this is addition, right? Well, what's the opposite of multiplication? Division, right? What's the opposite of addition? Subtraction. So when this happens, what you do is you subtract your exponents. You take the top one and subtract the bottom one. You also might need to know what a negative exponent means. That's going to come up sometimes too. If they give you a negative exponent, it does not mean that the number is negative or anything like that. It is a signal to you that this thing is secretly on the bottom of a fraction as a positive exponent. These are things that you should have learned a long time ago. I'm sure they didn't stick in your brain or anything like that. But write them down now and use them religiously. What do you do with your exponents when you divide? You subtract. What's a negative exponent mean? It's really on the bottom as a positive, okay? So keep that in mind, refer to that if needed, and then we'll go ahead and use those skills to start dividing some polynomials. All right, first thing to write down today, I don't think you need to write down the slide, but let me give you a little crash course real quick on what this slide is saying. If you're going to divide a polynomial by something else, make this little subnote to yourself, because this is like a minor topic right here. Dividing by a monomial. This is a subtopic. It's like an easy case of today, dividing by a monomial. What's a monomial? What's mono mean? One. I mean, like one thing, right? So if you divide by something that just has one term, look at what's on the screen right here. In fact, let's write down this example. This is a good example. I'll do this one on the board too. You have this thing divided by 3x. 3x is a monomial. It's just one thing. It's not 3x plus 2. It's not 3x plus 8x to the 9th or something like that. It's just dividing by one term. So make a note to yourself, what does dividing by a monomial mean? Divides by just one thing. Just one term. It's not something plus something on the bottom. It's not something else. Note to yourself, however, that has to be. So the example they're given is 6x squared minus 15x divided by 3x. My notes for you on this, if you are dividing by just a monomial, just one little thing, is I would say distribute the division. This is your note. This is your concept of how you just do a problem like this. You have a bunch of things on top. I don't care how many things are on top. 50,000 things. I don't care. If you're dividing by one thing, just one thing, what you do is you take every term on top and separately divide it by what's on the bottom. You already did that, didn't you? I think we did that back with quadratic formula. When I gave you this kind of junk, couldn't you reduce things? Remember when we did that? We reduced things. We take everything on top, both of these terms, we distribute the division. What's negative 4 divided by 2? It's negative 2, right? Plus or minus, what's 8 divided by 2? It's 4. So we already kind of touched on this. When you divide by something, you can divide the things on the top separately by them. And that's exactly what we're going to do right here. We're going to distribute the division. So for a problem like this, I want you to look at it 2 times. Ready? Forget this term. What if I had 6x squared divided by 3x? Well, I also want you to ignore the x's. What's 6 divided by 3? 2. Okay. So there's a 2. Now, what do you have when you have an x squared divided by an x? Well, here's the rules for division, right? What do you do with your exponents? You subtract them, right? So this is a 2, and this is secretly a 1, correct? And 2 minus 1 is 1. So this first thing is just a 2x to the first, or just 2x. That's just from this part. That's just from this guy, right? By distribute, I mean, let's do it to this dude, let's do it to this dude, let's do it to as many dudes as we got. Next person. Now we kind of ignore this guy. If I had negative 15x divided by 3, well, let's do one thing at a time, forget the x's. How about negative 15 over 3? Could you reduce that? I think you could reduce it to negative 5, right? And then even x divided by x. Now, what's x divided by x? Well, I don't know. Let's see. Let's go to our rule, right? That's x to the first over x to the first, right? And what's 1 minus 1? It's 0, right? So it's x to the 0. What's anything to the 0 power? Anybody know? It's 1. So actually, when this happens, this x and this x cancel out completely. If the same thing's on top and on bottom, they cancel out. So it's just a 5. So the answer for this one would be 2x minus 5. That's the whole darn problem. Let's see another example they got of that. Let's try this one. Write down this ugly mess that they put down on top. Not the rest of the work. We'll do it ourselves, but just the setup. Find 24a something, blah, blah, blah. A to the 4th, b to the 3rd, plus 18, a squared, b squared. Now, as you write it down, you might notice that this entire ugly thing in parentheses is times something raised to the negative first power. Now, this is why I harped on earlier. What does a negative exponent mean? It means it's really on the bottom. So when you're taking this thing multiplied by 6ab to the negative first, really what that means is you're dividing by 6ab raised to the positive first. So if you see a negative exponent like a negative 1, that just means it's on the bottom. That's it. So I'm not even going to write it like they did. I'm glad you did. But the first thing you should probably do is translate it into what I'm about to write on the board. So take any negative exponents and write them in the denominator. That's your big note for today. Take negative exponents and write them in the denominator. So your real problem looks like this. This divided by this. It was secretly a division problem. It didn't look like it. It looked like something times something. But the other thing was on the bottom, so it's really a division problem. All right. Let's go term by term and distribute the division. That's the whole point when you're dividing by just one thing. This is one thing. Here we go, term by term. I'm going to look at just this term, okay? You can probably do a lot of it in your head. This divided by this. Well, what's 24 divided by 6? That's 4. What's an a to the 4th divided by an a to the 1st? What do you do with your exponents again? You subtract them. What's 4 minus 1? 3, right? So we got 8th to the 3rd. And here's a b to the 3rd divided by a b. That'd be b to the 2nd. Exactly. It's coming back to, yeah, that's good. I like that. Next, middle guy. Let's do the same thing. Distribution. Here we go. 18 divided by 6 is just positive 3, right? So plus 3. A squared divided by an a, that's just an a, because 2 minus 1 is 1, right? 2 minus 1, a to the 1st, or just a. And same with the b's. You had a b squared divided by a b. 2 minus 1 is 1, so we have a 3ab there. And the very last term, this guy divided by 6ab, well, negative 30 divided by 6 is negative 5, correct? Here's an a and here's an a. If they're the exact same thing on top and bottom, what do? They cancel out. So I don't even need to worry about the a's. I got a b cubed divided by a b. That's a b squared. So we're all done dividing that monomial. Okay, and that's all there is to dividing a monomial. There's just one thing on bottom, no pluses, no minuses, no lots of terms. What do? The key thing is you distribute the division to every single term on top. It's just like 3 problems in one on this one. If I had 20 things on top divided by one thing, okay, I got 20 things to figure out what they are. Any questions over that? Okay, let's move on then. So that was not the heart of today. Here's what the heart of today is. Take a minute, write it down. Here's the theory. I'll tell you what it means in a minute. Of course, we're not always going to be dividing by one thing. We're going to be dividing by x squared plus 5x plus 9. We're going to be dividing by x minus 3. We're going to be dividing by lots of weird things. So we need something more powerful than what we just talked about. Something that will do anything, no matter what you're doing, including a monomial. If you want to use this for the monomial thing we just talked about, that'd be fine. It'd be a little bit tedious and pointless to do that. Make it too hard, but you could. Long division. when you take anything, this actually just goes back to grade school stuff. This is, I mean, it's all fancied up with x's and functions and stuff, but really what it's saying is if you take anything divided by something else, you get out an answer. The answer, the fancy word for the answer is the quotient. But you might have a remainder left over. Remember that? In grade school, you might have a remainder like, oh, 15 divided by 4. You go do the long division, you have a remainder left over. So in this expression, and I would definitely write this down, you have a function divided by another function. You start off with this, something called f divided by something called g, whatever they are. I don't care what they are. You'll get an answer out. But if you have a remainder, you have to add on the remainder divided by whatever you were dividing by. We'll hit this all very hard today. Make sure you have that written down. Q is the quotient, answer. R is the remainder. And if you have that written down, we will be okay. And we just need to do tons of examples because what the heck is this? You've never seen it before. And the book does not do a good job of explaining how to do long division. So I'll just show you myself. All right. Write down this example. Don't write down the work. I'll show you what the work's doing. But write down x squared minus 5x minus 36. And if you want to do a little grade school division symbol, be my guest. Or if you just want to write off the bat, just write it on the bottom, you can. That's what, either way is okay. Me, I never write the divide by symbol. I just put it on the bottom. If I'm dividing by x plus 4, okay, I will divide by x plus 4. So here's our example of doing some long division. But before we do, let's go back to something you know, because this is really just doing the same thing you did in elementary school. So I'm going to give you a problem here. 467 divided by 5. Now, you don't know what the answer is just by looking at it, do you? But you can figure it out. Do you remember how to do this stuff? Remember how to do this way back in the day? It's like 4th grade or something like that. Let's see if you know. How do you do it? Well, you see if 5 goes into 4, does it? Does 5 go into 4? Are you even worried about the other digits right now? You're just worried about the one in front, aren't you? And it doesn't go into it, correct? Well, what do you do when it doesn't go into it? You just go on to the next one, correct? Does 5 go into 46? Yeah. How many times? 9? So if you go into it 9 times, that gives me 45. Remember that? Now, do you remember what you do with this now? That's exactly right. So you're going to subtract these things. We're going to do a very similar thing over here on the board in a minute. And when you do, the 4 minus 4 is nothing, right? The 6 minus 5 is 1, right? What do you do with the 7? Yeah. Break it down. Yeah. And we're going to do the exact same thing in a minute. What do you do then? Repeat, right? Go again. Okay, 5. Does it go into 17? Yes, it does. How many times? 3 times. And you have a remainder left over, correct? So a weird way to write this is 467 divided by 5 is an answer. What was my answer? It was 93. But you had a remainder left over, correct? And usually when you were a kid, you'd like R2 or something like that. You know, yeah, we're not going to do any of that crap. Here's what you always do, according to that slide I just put up. You add on whatever the remainder is divided by what you were dividing by, which was 5. So here's what my goal is for you. I want you to get things like this in the end of today. I want you to get, hey, here's an answer plus maybe there's some leftover divided by some stuff. Does this make sense? Okay. Well, let's see if we can do it over here as well. So here's your first example of doing it with variables. You do the same thing. Remember, whatever you have on top goes inside of your bar. We are going to do it just like that in grade school. And whatever you're dividing by goes on the outside right there. Oh boy. Terrible 4. Like a ninja star or something. All right. Here we go. Ready? Here's the procedure. Ignore everything but the ones in front. Ready? Here's a thing, right? Where's the thing in front? X. Just look at this. Here's a thing. Ignore everything but what's in front, which is this. So you just look at the front. Ready? Now, what did you do over here? You figure out 5 times something as close as I could get to this, correct? Well, same thing here. X times what is x squared? Think about variables. X, right? So guess what I put up here? X. So you put an X up top. Now, what'd you do when you picked a 9 over here? You figured out it was 9. What'd you do? You actually multiplied by this thing, right? And wrote it down. So now, whatever you pick, you multiply by the whole thing, okay? You use the front ones to pick what goes up there. Whatever goes up there, you multiply by the whole thing. So what's x times all of x plus 4? Well, here we go. X times x is x squared, correct? And x times 4 is 4x. Take a minute and digest that. Does that make sense what we just did? We picked x. How do we pick the x? We ignored everybody but the leading people, right? What you choose up here is just based on the front people, correct? And then whatever you pick, you multiply by this whole thing, and that's what goes right there. And then what do we do after we picked what went right here? We subtracted, didn't we? Well, guess what we're going to do over here? We're going to subtract. I strongly encourage you to put that thing in parentheses. You need to subtract all of these terms, whatever they are. If it was x squared plus 4x, you're going to have to subtract x squared and subtract 4x. All right, let's subtract them, ready? This minus this. Well, this is just like elimination stuff back in the day. What's x squared minus x squared? It's nothing, correct? It's kind of the point. What's negative 5x minus 4x? That's negative 9x, would you agree? So down here goes negative 9x. You take this stuff minus this stuff. And then after you figured out this was 1, what'd you do? You brought the 7 down, correct? Well, what are we going to do over here? We're going to bring down the other stuff that we have dealt with, which is negative 36. So you bring it down. And that's essentially the procedure right there. We'll do this a lot. But after we got to the 17, we weren't done. We had to go all over again, didn't we? We started over again, like, oh, 17. Does 5 go into 7? Yeah, well, we're going to do the same thing here. Now I want to figure out, okay, how much does this go into this? And again, what you put up here, you ignore everybody but the leading people. So ignore everybody but the leading. X times what is negative 9x? Negative 9. So you put negative 9 up there. Whatever you put up there, multiply it by the whole thing. So negative 9 times x is negative 9x. Negative 9 times positive 4 is negative 36. And whatever you get out, subtract the whole thing. Now, in this case, it's going to work out nice and clean. Because isn't this thing the exact same thing as this? Well, anything minus itself is just 0. So in this case, our remainder was a nice clean number of 0. So another way to write this divided by x plus 4, which is the original problem, is, what was the answer? What did we get out when we did this divided by this? We got out x minus 9. So the answer is x minus 9. If there was a remainder, I'd add it on plus the remainder, but there is no remainder, so we don't need to worry about it. That's it. That's the whole procedure. Although it takes practice, and you can see how it could be jacked up, correct? You mess up one little sign in the beginning, just like anything else, it's going to trickle throughout all your work, and it's going to mess everything up, and that's not what we want to do. Let's do this one down here. X squared plus 6x, write this one down. I'll write it down too. X squared plus 6x minus 12. X squared. So they use the little division. They actually wrote the bar this time, this divided by this, which is good. You know, that's how I would write it too in my work. Is it 112? Oh, gosh, that would have made a difference. Thank you very much. Ouch, ouch, ouch. Did I do the rest right? Okay, we're good. Thank you. That would have worked out all wrong. All right. Well, here we go. Let's practice the skill again. What must you do? Well, again, how do you decide what goes up here? Every time you decide what goes up here, you ignore everybody but the leader, right? So ignore everybody. And x times what is x squared? X again. So we put x up there. Whatever goes up there, multiply by the whole expression, whole thing. Can't just do the x times the x. You got to do x times the whole darn thing. X times x is x squared, and x times negative 8 is negative 8x. So that is what's going to go down there after I've chosen the appropriate numbers. What do you do then? You subtract. Again, please put parentheses. Remind yourself you're not just subtracting this, subtracting all of this stuff right here. Then you subtract them. X squared minus x squared is nothing, right? 6x minus negative 8x. That's 6x plus 8x, right? Which is 14x. So after I subtract them, I got this 14x. There's something on the end that I haven't dealt with yet, hasn't come up in the problem at all, the negative 112, right? So you bring that down. You look at it fresh, and you say, well, let's go again. Let's go again. Something else I can add up on here? Well, I don't know. Let's look again. Ignore everybody but the leading people. X times what is 14x? Well, that would be 14. Would you agree? So 14 goes on top. And 14 times x is 14x. 14 times negative 8. I wonder what that is. My gut says negative 112. Oh, what a cute. There you go. And again, since they're the exact same thing, after you get that written down and subtract them, you will have a 0 remainder again. Actually, in practice, when we actually use this to solve problems, you will want to always have a 0 remainder, but we'll get into that another time. So the final answer for this is what? X plus 14. That divided by that is just a clean X plus 14, and we're all done. All right, let's try another one. Can't do enough of these. Oh, this one's got a remainder. Let's freak out. Here we go. This is your problem. It's got z's in it instead of x's. Don't freak. It's the same thing. X's, z's, whatever. So we'll use some z's this time. Just a letter. So 3z cubed. I'll make sure I copy it correctly. Minus 14z squared. They're getting bigger, aren't they? Minus 7z plus 3. And that's all divided by. Make sure you put things in the right place in the box too, right? Things on top go in the box, right? What you're dividing by goes on the outside of the box. Z minus 5. All right, you tell me, guys. You tell me. What do you do first? I'm going to take away the board so you can't see it. Oh, problem's gone. That's too bad. What? Can't start my camera, you liar. You don't have the camera. God, this thing is. I don't know what's going on with my tech. Okay, here we go. So, what do? Just look at the first people, right? You tell me, z times what is 3z cubed? 3z squared. You're exactly right. Yep, 3z squared goes up there. And whatever you choose that goes up there, make sure you multiply by the whole darn thing here. So what's 3z squared times this whole thing? Well, this times this is, by design, 3z cubed, right? In fact, shouldn't that always happen? You're picking the right thing. The first thing you write down should be the same as the first one because that's why you did it, right? But you're not done. What's 3z squared times negative 5? Negative 15z squared, yeah. And then I encourage you to put parentheses. I encourage you to remind yourself you're subtracting the entire thing. Well, that minus that 0, right? What's negative 14z squared minus negative 15z squared, guys? That minus that. It's just z squared. So we have a z squared left over when we've subtracted these. And then we're going to go again, but of course there's some other stuff that we haven't really dealt with yet, right? This stuff. Bring it down to, if there's any numbers off at the end that just didn't come up, write them down, you're good. So now I got a z squared minus 7z plus 3. In fact, every time you do this, your problem gets smaller if you haven't noticed. This started off being a cube thing, right? After I did it once, now I'm down to a squared thing. If I do it again, I'll be down to a linear thing. Eventually, I'll whittle it down to something that I can do. All right, what do you think goes on top next? Just what? I couldn't hear. Plus 2? No, not 2. How about z? I think that's what we meant, right? Because z times z is z squared, so that's what we're going to pick. But wherever you pick, make sure you multiply the whole thing, right? So z times z is z squared, and z times negative 5 is negative 5z. And for God's sakes, make sure you put a big parenthesis and subtract the whole thing. Okay, the z squareds are gone. That's the point. You tell me, guys, what's negative 7z minus negative 5z? Negative 2z. So I have a negative 2z. There's still this 3 that really had nothing to do with anything. That's just chilling. So it comes down also. And we're pretty much there. Let's go one more time. Now I got to figure out how much this goes into this. Well, z times what is negative 2z? Clearly it's negative 2. Negative 2 times this expression, negative 2z. And negative 2 times negative 5 is positive 10. And whatever you pick, make sure you write it all out, put in parentheses, and subtract it. So this time we are going to have a remainder. That means that this does not go into this, just like numbers work. The two z's go away. 3 minus 10 is negative 7. So there's our answer, but we have a remainder. So we want to be careful how we write our answer. The answer to this divided by z minus 5 is the answer, which was 3z squared plus z minus 2. But when you have a remainder, You've got to add it on. So I'm going to add on this remainder of -7, but -7 out of what? You were dividing by something. What were you dividing by in the first place? Z minus 5. So the remainder is still divided by Z minus 5. So if there's a remainder, that's all you got to do. Just add on whatever it is divided by what you were dividing by, and that's all for theirs for life. Their examples don't quite cut it today. Let me give you another one, because this is going to be a pitfall of yours. Try this one out. X cubed plus 2x plus 6. Actually, wait, I'm not going to do the bar yet. Divided by x squared minus 1. How about this? Ooh. You know what I'm talking about this?
Oh,
yeah, you know exactly why I'm doing this. All right. Now, here's my advice on this one. We're going to write it out. But look at this top one. Does it have every kind of term it could have? It's got a cube, right? Does it have a square? I don't think it squares. Crap. How about down here? It's got a square, right? Does it have just an x thing? No. Here's what I really strongly encourage you to do for bookkeeping so you don't jack this up. When you write this out, if there is a term missing, please, for bookkeeping, write that there are 0 of them. So write plus 0x squared. This will save your life as far as organization goes. Do you have to do this? No, but I guarantee 99% of the time you'll jack it up if you don't have a placeholder. So I have an x cubed. I have no x squareds. I have a 2x. And I have a 6. So the moral of the story on this one is if there's something missing, please write as a 0 something. And same for this dude. This is x squared minus 1. Well, I'll write as x squared plus, there's no x's, right? There's no just x. So I'll probably put 0x. And I'll put a minus 1 there. So I know it seems clunky to put a bunch of zeros in there. And it kind of is. But it'll make your life so much easier as far as not jacking it up. So here we go. Ooh, this got an x squared in front this time. Time to freak out. Well, again, it's the same procedure no matter what. Look at the leading people, right? X squared times what is x cubed? Just x. So I'll put an x up there. And whatever I choose, I multiply by this whole darn thing. So x times x squared is x cubed, correct? Now the 0 is just there, so I have things lined up here. So when I subtract them, they're just all like terms. X times 0x is just 0x squared. Again, it's just 0, but it'll just keep track of it. And x times -1 is just -x. Now, when you do this, look what the zeros do. Everything's lined up, right? Cubes are lined up with cubes. Squares are lined up with squares, right? X's are lined up with x's. So that's why I want you to put zeros in there. So you won't mess it up, and so everything will line up, and you can never possibly jack this up. All right, let's finish it up. X cubed minus x cubed is nothing, right? 0 minus 0 is 0, right? So really, I just have 2x minus -x. And 2x minus -x is 2x plus x, or 3x. So there's a 3x after I get to that. And then you get the plus 6 here. It's just hanging out. And then we ask ourselves, can I go again? Can you go again? Can you multiply x squared by something and get just x? Not really. So you're done, aren't you? Can you get a remainder that has x's in it? Yeah, you can. So the final answer to this is, this divided by this is, the answer I got out was just x, right? But I did get a remainder. Whatever the remainder is, how do you deal with it? You just add on whatever the remainder is, divided by what you were dividing by, which in our case was x squared minus 1. I don't need to write a 0x in that one. That's just for bookkeeping. Okay? You don't need to write 0x in practice. It's pointless. All right, how do you feel about that, guys? Yeah, okay. Well, we'll find out. So that's what your homework is about. And again, this will be building on itself and be used all the darn time going forward. So finish up 4.3, and you don't got much time left in class, so maybe start looking at 4.4, something like that. And if you got questions over it, please ask me on it. Be really careful, subtract things just like we talked about. Little things are going to get you on this. All right, that'll be that. Tomorrow's work day. Get 4.3 done. That's it for me.